So yes, I'm going to talk about how we use evidence chains to predict nature's contributions to people, or NCPs in short, under conventional and organic farming systems across Europe. Most of you will know that sustainable soil management has or provides enhancements of the delivery of nature contributions to people, or NCPs, which is a similar kind of concept as ecosystem services, just a little bit broader. And sustainable soil management is at the core of organic farming. And under the European Green Deal, there is a target to reach 25% of agricultural lands under organic farming by 2030. And of course, to reach such targets, there is a need to make informed decisions by farmers and policymakers to know where to convert to enhance actually the delivery of these NCPs. So here in this talk, I will focus on 4 different NCPs or functions. So first, soil organic carbon, which is related to climate regulation. Then we have crop yield, which is related to food and feed production. Then we also have hydraulic conductivity, which is related to water infiltration into the soil and therefore can prevent flooding. And then finally, we also have saturated water content, which is related to the potential availability of water in the soil and therefore related to also the availability to crops, for instance. To inform our modeling, we started building some evidence chains, which are basically linking soil management. And here specifically, this is conventional versus organic farming systems, and also some environmental variables like soil variables and climate variables, and linking those throughout through the system to NCPs, and then also the valuation of these NCPs. And these evidence chains are based on an understanding of the processes that are happening in the ecosystem, and are also backed up by evidence found in literature. And that's also, the arrow thicknesses represent this strength and evidence found in literature. And this is specifically an example for soil organic carbon, but we built these for each of the functions and NCPs that we actually modeled. And then, of course, the next step was to actually operationalize these evidence chains by building models. And for each model, we had some requirements. So, of course, we need a model to actually be able to predict these NCPs from a farming system, so conventional or organic. We also need, and also environmental variables. We need to be able to economically evaluate each of these NCPs. And then also finally, we need a map layer for each of the predictors. So we were able to map it at the end. And so for each of the models, we used a specific approach that was based on the availability of data and also the availability of evidence out there. So for instance, for soil organic carbon, we built a statistical model that was based on the data collected in the project and also added to that literature data. And then we also used avoided cost of societal damages due to climate change as a means to actually economically evaluate this. Then we have also crop yield. For this, we again scanned the literature to find studies that actually looked at this kind of difference in crop yields under conventional and organic farming systems, and then use potential crop yield maps as a baseline, and then crop yields or market prices to be able to economically evaluate it again. And then finally, for hydraulic conductivity and saturated water content, we use a established model, the Rosetta model, and we're able to economically evaluate saturated water content using irrigation cost avoided. And if you want more information about this specific model and how we used it and what assumptions we made and how we looked that up in evidence, you can go to Maud's poster that is also presented here. So now I will present some results of our modeling. So each of these NCPs we can map. So here you can see how saturated water content varies under conventional farming. And then we can also obviously map this change from conventional to organic farming. And here it's specifically expressed as an economic value. And I will go a little bit deeper into like some comparisons of certain regions. So here we're looking at the Atlantic, continental, and Mediterranean region, and then some different soil types as well, coarse, medium, fine. And wait, so looking at how the distribution of these the soils or saturated water content change, so the value change across these different regions. So here we can see that for coarse soils, it's quite a small change compared to the medium and fine soils. And also interesting to see is that the range is quite narrow, meaning that there is less variation in these types of soils if it comes to the value change. And then for Mediterranean soils, there seems to be a better opportunity for change based on our models. It's also interesting to actually compare multiple NCPs. So like looking whether there's any synergies or trade-offs between these NCPs. So if there is an increase in one NCP, is there actually an increase in another one, or is there a decrease in another one? So here we're comparing saturated water content and barley yield as an example for yield. But it doesn't necessarily seem that there's any correlation. So there's no real synergies or trade-offs. Then, for instance, if we look at change in saturated water content and organic carbon stock, then there seems to be some kind of correlation, especially in the Mediterranean, where an increase in saturated water content is often related to or at the same location as a change in organic carbon. So there is a synergy there. So just to conclude, so in summary, we use these evidence chains to inform our modeling, and we modeled the change of NCPs under different soil management practices with a focus on conventional to organic farming systems. And then under organic farming, we can see that there's an increase in value of saturated water content, with a greater increase in the Mediterranean and smaller increases in coarser soils. And that there is a synergy between the saturated water content and soil organic carbon. And as next steps in our project, we also want to include other soil management practices to actually not just look purely at conventional versus organic, but look at actual practices done under these farm systems. And then I also want to explore different scenarios, not just looking like if everything is conventional or if everything is organic, because those are not necessarily feasible scenarios. So thank you all very much for your attention.